Alrighty, in this video we are going to be talking about Newton's cooling in terms of growth and decay. Newton's cooling states that the rate of change in temperature of an object is proportional to the difference between the object's temperature and the temperature in the surrounding medium. This is given by d capital T over d small t is equal to k times T minus T sub s, where T sub s is my surrounding temperature, which I didn't say in the notes, but T sub s is my surrounding temperature. All right, and we want to find the general solution to the differential equation for Newton's cooling so that we can work with number 11 and 12. So here, remember, we are going to use separation of variables. So I have 1 over T minus T sub s d capital T is equal to K d small t. I am going to integrate both sides. I'm going to have ln of T minus T sub s is equal to K small t plus C. Now, remember that here I'm going to have to use U substitution. And because I'm integrating it with respect to T, I don't have to have a negative sign because T is positive here. All right, I am going to take the E of both sides now. So that's going to give me T minus T sub S is equal to E to the KT plus C. Now remember that E to the KT plus C, that this C can be put up front because remember I could break this apart to look like this, and then E to the C is just C. We don't know what that value is. So C, and then since I'm solving for T, my temperature, T is equal to CE to the KT plus T sub S, my surrounding medium. So this right here is going to be my general solution for Newton's law of cooling. All right. So number 9 says, let Y represent the temperature of an object in a room whose temperature is kept at a constant 60 degrees. So this constant 60 degrees tells us that this is my surrounding medium. So T sub S is going to be 60 degrees. The object cools from 100 to 90 degrees in 10 minutes. How much longer will it take for the temperature of the object to decrease to 80 degrees? All right, so the first thing that we need to do is find out what C is. Now, C is not going to be 60 degrees, and C is not going to be, 90 or 10. We actually need to figure out what C is based off of my formula that we derived in number 8. We have big T is equal to CE to the KT plus C sub S. We know that my temperature was 100 degrees. My initial temperature was 100 degrees at time 0. So I have C, E to the 0, plus my surrounding medium, which is 60. So to figure out what C is, I'm going to subtract 60, which gives me 40 to be C. So that's step 1. Step 2, of course, is to find out what K is based off of what I know. So now I know that C is 40, and we know that my surrounding temperature is 60 degrees. All right, so it goes from 90 degrees in 10 minutes. So now I have T being 90, and then my temperature being 10. All right, I am going to subtract 60, and that's going to give me 30. I'm going to divide by 40, so that's going to give me 3/4. I am going to take the ln of both sides and then divide by 10. And that's going to give me the value of K. Okay, step 3 is going to give me my final equation. So that's going to give me T to be 40e to the ln of 3/4 over 10 T plus 60. Okay. Now, it says, how much longer will it take for the temperature of the object to decrease to 80 degrees? So I'm going to substitute in 80, and I'm going to figure out what T is. Subtract 60, so that's going to give me 20. And then once you do that, divide by 40, so that's going to give me 1/2. All right, once we do that, I'm going to take the ln of both sides. So you have ln of 1/2 is equal to ln of 3/4 over 10 times t. So then you are going to get t being 10 ln of 1/2 over ln of 3/4. Now, this is going to be very important. This answer right here is not your final answer. The reason why is because it tells us how much longer will it take for the temperature to decrease to 80 degrees. So what we're going to do after we get this time, you're going to have to evaluate this, is to subtract 10 minutes. And the reason why we're subtracting 10 minutes is because initially, from 100 to 90 degrees, that took us 10 minutes. So it's going to take us an additional however many minutes to get to 80 degrees, which is what we need. So what we're going to do is evaluate this, subtract 10, and that is going to give us the amount of time needed to decrease temperature to 80 degrees from our 90. So in this case, my final answer is whatever this is, and I don't know what this is. You're just going to have to evaluate this and then subtract this by 10. And that's your final answer. All right, now the same process can be done with number 12. So what I want you to do is pause the video, try number 12 on your own, and then play the video and see if you got it right or not. It's the same process. So we have my formula. Using that formula, I know that my surrounding medium is 20 degrees. I also know that the initial temperature is 160 degrees, and that's going to give me 160. C e to the 0 plus 20, meaning that C is going to be 140. And then it tells us after 5 minutes, the liquid is now 60 degrees Fahrenheit. So I have T is equal to 140, e to the KT plus 20, substitute in 60. After 5 minutes, I'm going to subtract 20. And then I am going to divide by 140. That's 2/7. I'm going to solve for K. So K is equal to ln of 2/7 over 5. Step 3 is to put everything together. So that's going to be 140 e to the ln of 2/7 over 5 times T plus 20. We want to figure out how much longer to decrease to 30. So this is 30. All right, so that's going to give me 10. Then you're going to divide by 140. Take that on both sides. and then solve for t. And remember that this t does not represent your final answer, but you're going to have to subtract from how many minutes we started off with. In this case, 5 minutes. So that means that we're going to subtract 5 minutes from this time to give us how many more minutes it will take for us to decrease to 30 degrees Fahrenheit. So this right here is your final answer. All right, Griffin decay isn't really a bad lesson. You just have to figure out, of course, in summary, find out what your C is, find out what your K is, make your formula, and then solve.